Well, down here, real quick, before we do this one, how would I rewrite this one? I'm dividing inside, so what do I do with the powers when I'm dividing? Yeah, so the power on this minus the power on this. And of course, log base 3, 3 again is 1. Now coming back up here, I'm adding, so to recombine them into one log, what do I do with the insides? Yeah. And what's 1/3 times 12? 4. And what's log base 4? 4. 1. Yeah. And this is another one. I can't do either one of these things by themselves. But since I'm subtracting, how can I rewrite this? Yeah, dividing. So I'm going to put and what is 75 divided by 3? 25. And what's log base 5 of 25? 2, because that's the power of 5 needs to become 25. I love it. Logs are not difficult. The properties are a little funky. You're not used to it. And they do sound like the power properties, but you're still not used to doing this kind of weird shit. How does the subtraction become division, Jeff? Because they're powers. And that's what powers do. The big mistake I see people make, so this is wrong. This is magic shit right here. You see the difference? I mean, this is saying that subtraction is division. So they took exactly what I was subtracting and just decided to divide them instead. This doesn't make any damn sense. Now, some of you guys might be like, well, Jeff, this doesn't make any damn sense either. Shit. But since this is a power and this is a power, when do I subtract powers? When I was dividing the things that the powers were on, right? Maybe. And that's why that makes sense. I'm not taking what I'm subtracting and dividing them, am I? I'm taking the log of the division of the insides. It's a property of logarithms. This one says subtraction is the same as division. Well, that's bullshit. We know that's not true. So this doesn't make any sense. Okay, maybe. But I can see why a student would make this mistake. Like, subtraction becomes division. That's what Jeff said. Not really. What do I do with this weird thing? What's the base? Good. It's under 10. Think about log base 1 real quick. Log base 1, there's only one thing I can put here to make it make any sense. Log base 1 of 2 would be what? The power that makes 1 needs to become. Any power on 1 makes it 1. So log base 1 makes no sense. In fact, what's this? Log base 1 of 1. All real numbers. What's 1 to the second? 1. What's 1 to the 18 billionth? 1. What's 1 to the negative 48th? 1. So log base 1 is no, there's no such thing. So this guy is base 10. That's the common log. Because our number system is based on 10, so log base 10 is the most commonly used logarithm. Just like a square root doesn't have a 2. This doesn't have a 10. It's just known. How do I rewrite this? Log of the quotient.
Log 10.
Log 1 minus log 10. And what's log 10? 1. And what's log 1? What's any log of 1? What do you raise something to make it 1? You raise it to the, what do you raise? Yeah, to the 0 power. So log 1 is 0. So I get negative 1. Now think about why that makes sense. What is 10 to the negative 1 power?
Oh, flipped.
1/10. Yeah, so you could have actually just done it directly, but oh well. I didn't let you think about it. Haha. So that answer makes complete sense, because 10 to the negative 1 is freaking 1/10. So that's the power 10 needs to become 1/10, negative 1. Maybe. All right, what about those last 3? Have you guys done those yet? Basically, whenever I'm working with logarithms and I have radicals inside them, what's the first thing I should do with those radicals? Because what are logs based on? What are logs all about? Logs are all about the power. So if I have a radical, that's a horrible form. So if I have a square root, I better rewrite it as something to the 1/2 power. So whenever I have radicals in logs, I'm going to rewrite them as power. Because what do logs care about? Powers. That's all logs care about is getting power. They're little trumps. All right. So like this guy, this property of logarithms is kind of a neat one. Like I told you, it's the most important property of power. So we're going to see why in a minute. But all that happens really is, since the inside is being raised to power, that power can just come down. Let's really see why. What would log base 3 of a times a? Isn't that what a squared is? And then I can use the property for multiplication. How do I rewrite the multiplication? It would be log base 3 of a plus log base 3 of a. Well, how many log base 3 of a's do I have? 2 of them. So why would I do all this shit? Why would I just take the 2 down? If it was 3, there'd be 3 a's. There'd be 3 of these, so there'd be a 3 out front. Why wouldn't I just take the 3 down? So it really is a shortcut, but we make it a property. So we just do it directly instead of rewriting 80 a's if I have an 80th power and going a little insane. I just make it a property. So what about, so that's the first one. What about the second one? So what do I have to do first here? Yeah, so it's x to the 1/2. And then I can do what? And by the way, real quick, let me just point this out, because this is the first function we've seen that has like a little word is what the function is. Would this make, if I said solve that, what? If I said solve this, what's missing? Yeah, anything. I could put a squared in there like, solve what, Jeff? You haven't finished the question yet. So if you write this, it makes just as much sense as this does. It's empty. That's empty, right? So is this. Log of what? The shit. So yeah, if you're writing an English sentence, I fill off the log, that makes sense. Then you're going to say, it's empty. Well, the log was hollow. How'd you know that? No, that's empty in math. There's nothing in there. It doesn't make any sense. Do you guys see what I'm saying? It's a different symbol. We're not. It looks fine, but it's just like an empty square root symbol. Doesn't mean a damn thing. So what about this last one? This last one, to be honest, you don't have to rewrite the radical. You can. There's nothing wrong with it, but what can I do with the power? Same thing I did here, right? That just comes down. Now, if you rewrite it as r to the 1/2, you're not wrong. It's just you didn't have to, really. Because the square root of r was the power. It just comes down. Why did I have to do this one? Because the power is coming from the root. Shit. Okay, I kind of, there's a question somebody had earlier that relates to another level of this, but I want to get right into equations and then I'll come back to that question on the practice final. So already got this here? So I want to show you why this is the most important property. And my second example will show you. I want to start off with something related to something we did earlier. Now these are equations with exponential stuff in them. How would you solve this equation? Let me see if you guys can figure this out. We did one, in fact we might have done exactly this one earlier. I can't remember.
Log.
No, I don't have to do any logs. I'm going to do a log here. Let me. So here's an equation I can solve without using logarithms. And here's an equation that I need logarithmic help. Okay, why? Because 16 and 8 are both based on 2. Remember that we did earlier? So if I had 27 and 9, or I had 4 and 64, if I had two numbers that were both based on the same thing, I could do what I'm about to do. Yeah, I think it was exactly this one. Almost this one. I think it was 1/8. All right, I can do all that stuff. Right? Doesn't feel very new, but it's rewriting things so they have the same 2. So all I need now is 4x to equal 3, and then the equation makes sense. Now, why can't I do that here?
Because they don't share anything.
Yeah, 15 is not based on 2. It's not based on 8. They're not based on the same. Oh, shit. Jeff. Now, does anybody have the calculator with them? I didn't bring my calculators today. It's too bad. If you have a calculator, look at your calculator. Do you have any log stuff sitting on your calculator's face?
Yeah.
What do you see? What kind of logs do you? I teach math. I know what it looks like. I want you to look at it. Sorry. If I don't know what my calculator looks like, I need to leave. What do you see related to logs? Sure, but what about just logs directly, more direct? Do you see any log stuff?
On the left side.
Yeah, what do you see?
Uh-huh.
Oh. I love you guys. You should see log. You should see log. Do you see it? Is it above, if you have a graphing calculator, is it above the button? I can't remember. Or is it a button?
There's a button.
All right. And then what else do you see?
On top is 10x and
Sure. Now somewhere you should see something related to something we talked the other day. Is a special log. What's the special log? Yeah. And what's the log form? ln. You see ln?
Yeah.
Okay, now we're gonna have to. Everybody else, they're gonna be our consulting team. In order to solve this equation, in order to solve any freaking equation, I want you to realize this. Side note, how would I solve this equation?
Multiply by.
Yeah. Say it.
Multiply by x.
Yes, why? Because the x is stuck in the bottom. I want to free the x up. What would I do to this?
Square.
Square, because the x is stuck in the square root. I got to do something to get it unstuck. Where's my x stuck in this silly thing? Stuck in the power. What's the only thing that can get something out of the power? Log. What? Look what happens if I take, let me just go and take the log on both sides so you don't freak out too much. I love you guys. The square root would work if the power was 2. What's the power? I don't know. Square root can't do shit for me. A logarithm makes what happen with this? What's the x? What can I do with the x now?
Bring it to the front.
Yes, right? Just like the ones we just did. That can come down. X times log 15 equals log 8. Now this is going to be a weird question. I don't want you to tell me the answer, but what is log 15? Is it a variable? What is log 15?
A power.
True, but it's a number, isn't it? Is it a pretty number? Probably not, right? You guys see what I'm saying? What's the square root of 11? I don't know, but it's some number, right? Is it a pretty number? No. So what's log 15? It's a freaking number. So x times a number equals a number. How do I solve for x?
Divide.
Divide by the stupid number I don't want. So I get x equals log 8 over log 15. Answer. Now you can put it in your calculator. Those of you guys that have a calculator, you got to be a little careful when we do this. Do I have my calculator? All right, for the rest of you, just take notes. But when you put this in the calculator, it opens a parenthesis for you. When you hit log, so log button's right there. When you hit log, get out of there. It opens a parenthesis for you, right? So if I want to put this in the calculator, I got to do log 8 close parenthesis divided by log 15 close parenthesis. So up here we got 3/4. If I raise 16 to the 3/4, I get 8. Do you see how 15 is a little bit less than 16? So the power's got to be a little bit bigger. to make it become 8 again. And sure enough, when you put this in the calculator, you get, what do you guys get? Anybody get that? Yeah, 0.76, let's say 8, rounded to there. A little bit more than 3/4, a little bit more than 0.75, which is what 3/4 is. So that's why that property of a power coming down is the most important property, because it gives me a way to solve when I can't do this. How the shit would I solve this? Logs come in and say, I got you. Oh, you like that. All right, so since most of us don't have a calculator, you can at least solve this down to this level here. Try to solve this equation. What you got, Jeff? I don't know, man. All right, guys, so help me out. What's the steps on this?
You bring down the x.
Can't do that yet.
Or you write it, rewrite it.
I've got to take the log of both sides first. Then you can, because what is that coming down is the property of logarithms. I can't do it until I get the log in there. So really what I just did is kind of equivalent to, what would you do to solve this? Take the square root of both sides, right? Because you're going to pull some out, all that kind of weird shit. Then you can kill the 2. So here, how do I start to solve this? I take the log of both sides. Then you can bring the x down. So the x comes down. And then what do you divide by? Log 11. You've got to realize this is one thing. Log 11 is a number. You can't divide by 11. There's no 11 there. So x is log 29 divided by log 11. This is what's known as the exact answer. If you put it in decimal form, you can never give me enough to make it exact. Right? How long? I rounded it off. But this goes forever. So to be honest, this is a better answer. But for most humans, we prefer decimals, right? What the shit is this? So is anybody with a calculator, can you do that for me?
1.078.
1.078? Okay. Yes? No?
It doesn't matter.
What? What doesn't matter?
I got something different, but.
But that matters. What are you talking about? We got dissension. I like it. Controversy. Let's see. Oh shit.
But we don't have, that's not the answer we have to write anyways, right?
Not at the moment, since most of us don't have calculators. But on a test, I might ask for a decimal approximation. I got something different. What'd you get, Alyssa?
1.40.
Yeah, I got 1.404. So be careful. Remember what I said, it opens a parenthesis. If you don't close it, everything else is also in that log. That's why I hate that. It's sort of like Microsoft Word. It'll say, did you mean this? No, stop it. I meant exactly what I wrote. I don't know. If you never use Word, you have no idea what I'm talking about. But it gets annoying as shit. All right, so if I say the exact answer, I don't say it, you can stop there. If I say, give me a decimal answer rounded to 3 places, you better be able to go one step further. Put in the old calculator. like it. Maybe. So now, here's another type. So these are exponential equations, right? They have variable in the exponent. Here's a logarithmic equation. We actually already did this one. I'm going to do 2 more examples. We did one like this already. Believe it or not. How do I solve this? How would I rewrite this logarithm as an exponential form? What did it hold? 3 to the negative 1 equals x. You can always rewrite any log. Because what's the answer to log? A power. On what? On the base. Okay, the base to the power is that. And did we just solve it? Do we get x equals a number? Yeah. What is 3 to the negative 1? 3 to the negative 1. 1/3. Yeah, there you go. We solved it. So some logarithmic equations, to solve it, you just have to rewrite it. And then simplify, and you're done. That kicks a lot of ass. Now what's wrong with this one? Oh, let's see. Let me make it like this, sorry. I think this should come out to a nice answer. We'll find out. What's different between this and this? What's obviously different? What's the most obvious difference between these two? How many logs are in this one? 1. How many logs are in this one?
2.
Damn. So if I can rewrite this to have a single logarithm, I can solve it the exact same way. If only I had a property for combining logs when they're being subtracted.
Log 2.
Yeah, so it'll be log base 2 of
X divided by X
Good.
minus 1.
And now that I've gotten written as a log of something equals a number, I can do exactly what we did here. How can I rewrite this? 2 to the second power equals, finish that out. Some of you guys are going to look at it and give up immediately, and I'm like, come on, you can do it. What sucks about this problem? Stupid fraction. Okay, kill the stupid fraction. It's an equation. You can kill things. So I can multiply both sides by x minus 1. Kill that. So I get 4x minus 4 equals x. And I'm just a couple steps away. You guys hear it?
Yes.
Okay. Just want to make sure it wasn't me. So subtract the x, add the 4, divide by 3, you get x equals 4/3. Now, do you remember what you had to do when you had square roots in an equation? When you got answers, you had to do something. When we had square roots in an equation and we got answers, we have to do what? No. When I had an equation with square roots in it and we solved it, we had to make sure that the answer
Positive.
worked. It didn't make the inside of the radical negative, right? We had to make sure it worked. Do you guys remember doing that? No. We get what's called extraneous solutions, which sounds painful. Extraneous. Logarithms have something similar. Does anyone remember what a log looks like if you graph it? What's an exponential look like? Can you do it in the air?
A curve.
Do more? Yeah, I see it. Okay. I just saw you do this. I'm like, yeah. So it's like this, Right? So what's a log look like? Mirror image. So it's sort of like a root in that it can't handle negatives. So if I put 4/3 in and it makes either one of these negative, I got to throw it out. But also they can't handle 0. So they're a little worse than radicals. They can't handle 0. So if I plug this in and it makes the inside negative or 0, I got to throw it out. 4/3 doesn't make either one of those negative or 0. So it's fine. I don't have to kill it. It's not extraneous. So logs are very similar to roots. And there's another place where they're very similar. They have similar domains. I've got to check that. Okay. Here's the thing related to a question somebody was asking me about. How would I combine those? How would I make a single log out of both of those? I don't have any property that tells me what 3/4 of a log minus 2 logs does. Do you see how the coefficients are in the way? If only it was log base b minus log base b, then I have a property for the difference of 2 logs. So how do I get that 3/4 the hell out the way? Where can it go? Where did it come from? What property of logs? Yeah. So I can put that back up here. Get it out the way. So over here, what do I do? Now how do I do the difference of 2 logs? Log base b of, what goes on top? M to the 3/4 over a squared. There you go. Cool. So there's a problem. You'll see some problems. There's a problem on the practice final like that. It's got a third part to it, but you just do that. You just get the coefficients out the way, and then you can use a property to put them back together. So that's in the homework you'd see it says, express the following as a single logarithm. That's what they mean. Get it all together into one log. Holy shit. So, I'll tell you this. Officially, that's the last thing we'll discuss that you'll be responsible for is 12.6. You understand what I just said? So everything through 12.6 is due. I will talk very briefly about chapter 13 and 14 tomorrow. Very briefly, just so you can see what it's dealing with. If any of you are going to take pre-calculus, they will go over that again with you. But I want to give you a little bit of a preview. And if you're not going to take pre-calculus, you can just stare at your favorite wall if you want to while I talk about it. It's up to you. Did everybody get a practice final? Do I have any? Shit. I should have probably checked first. Oh, that's it. Yeah. No, that's the practice test. Shoot. No. No. Darn it. I thought it had some. Oh, here we go. There we go. I found it. Maybe nobody needs it. Everybody needs it. Okay, good.
I have a question.
Yeah.
On the homework you handed back, it has like no work and stuff on it. Is that just?
You're fine. So I was preparing you for this day. I said you might get a lot of stuff back from me that was never looked at because either you did fine on the test, so I didn't need to look at it, or I just ran out of time. So I'm just assuming it's okay. Unless it was something really obvious, like I love some people just turn in, they write the problem down, but they don't do anything. And they're like, I don't know what kind of teachers you've had in the past that were stupid enough to go, oh, they did it. I don't know. But, so maybe if you did that, you didn't get any credit. But otherwise, I just gave you credit for it. So if you want to, for example, like the last, starting at O, 1 O, P, Q, R, S, that's all related to the log stuff. and exponential stuff. If you want to kind of do that now, I don't, just to start reviewing. And then number 3, I, J, K, or I'm sorry, I and J, they're related to what we just did. Right? So if you want to try those out right now, you can do that, and then we can look at them. It's up to you. I thought I'd try to start a little bit of final review today. Yeah.
Could you just go over again what a natural log is?
Yeah. All right. So, for example, real quick, there's a number between 3 and 4 that circles are related to, and of course we give it that symbol pi, right? And Carrie's like, I know what the free pi is, dude. All right, no, you're not saying that. And it came out from, no matter how big the circle is, if I take the circumference divided by the diameter, I kept getting the same number, so we gave it a symbol. There's a number in between 2 and 3 that has come up in a lot of strange places. Let me just give you one example. If I graph the y equals 1 over x, okay, it looks like this on this side, it looks like this on that side, but I don't care about that side right now. And I go from 1 to something, and I get the area there. Let me just stop there for a second. That's a really strange question already. But if I graph y equals 1 over x, and I start at 1, and I get the area underneath that graph. Are you guys semi with me? Where do I stop so that this area is 1? I stop at the number e. I mean, that's just one weird little place. It also comes out of something called continuously compounding something. This is a financial idea. E kind of comes out of that also. And yesterday I talked about the fact that E is often used to represent population growth. It's the one number that captures the rate of growth of rabbits or whatever else you got. Okay? And it's 2.7. I always forget exactly what the hell it is. Something like that. Blah, blah, blah. So it's just like pi in a way. Pi came out of a really weird place. E came out of several different disconnected places. So we're like, holy shit, we're going to give this thing a letter because it's a nifty number, right? So you see pi in all kinds of places you would never expect it. Same thing with E. It just seems to be a fundamental property of how things work. It's really neat. So that's all E is. And so I'm going to do this one more time for you, okay? I'm never going to do this again because it really hurts to do that. I don't know if you believe it, but that hurts to do this. We don't use that, we use this. So ln, since E represents growth of populations or decay of radiation, very natural processes, we gave it the name natural log. So the log base E, we call it natural log. That's why it's ln. Log de naturel. I mean, it was some French dudes did it in the first place, so that's why it's backwards. You guys kind of with me? So there's all kind of stupid math jokes about natural log cabins and shit. I'm going to obviously spare you from that. And you're like, why didn't you spare us from your other stupid jokes? I can only do so much. So that has all the same properties that other logs do. It just is a special log. It's just like square root. Just because it doesn't have a 2 doesn't mean it doesn't have the same properties as roots. It's still a root. Yeah?
Okay, can you do number R then?
Oh, okay. So, in general, if I have log base b of b to something, what happens to these things? What's the cube root of x cubed? What happens to these things?
They cancel.
Because the cube root and the cube are opposite operations, right? Well, log base b and b to the power are opposite operations, so here you would just get x. So as long as the base is the same as the base, they will kill each other. So what's the natural log of e to the x squared? Well, what's the base of this known to be? What's the base of ln? E. Remember, ln really is log base e. We just gave it a special symbol. So that base is e, and what's this base? E. So what do these do to each other? Kill each other, so the answer is x squared. Isn't that kind of neat? Semi-neat? A little bit neat? So what about this? What's e to the natural log of y? Y. I love it. Boop. Any two inverse functions, when one is acting on the other one, they will kill each other. That's their fundamental nature. It's like the anti-function. Could have called it, instead of inverse function, it could have been the anti-function.
Thank you.
Oh, sure. Anytime. So you guys, in general, you got to stop looking at this like some other people did this. Math is for other people. No, you're a human. This is you. This is your shit. Right? Do you understand what I'm saying? We made this up. And now I'm a person trying to communicate to you what the shit we made up so we can all talk the same. Don't look at this like, that's weird shit I don't have to worry about. Somebody else did that. No, this is just humanity came up with this shit. And it's useful. Believe it or not. Could you live your life never knowing this? Shit, yes. Could your life be a little better maybe if you knew some of this? Of course, yes. Right? That's what I hate when people are like, I don't need to know that shit. I'm living a good life. I'm like, that's fantastic. You don't know how much better your life could be if you just knew a little more. Right? All right, so I don't know why I had that rant. I was just sitting in my brain waiting to come out.